Hi, my name is Raz, and welcome to the second video in the series Learning SolidWorks. In this video, we'll have a look at assemblies, and you'll learn how to put your newly designed parts into an assembly. Learning to work with assemblies in an efficient way is an extremely powerful tool in designing products. You'll be able to design new parts that are related to the assembly, and by the end of this video, you'll learn how to design new parts in an assembly context. Before we get started, I need to mention that none of these videos are sponsored by SolidWorks or Dassault Systems. The opinions that are expressed in these videos are fully my own. If you don't have SolidWorks installed already, please check out the video in the description below on how you can install SolidWorks Maker and get started. In the previous video, we designed these two parts, a light cylinder and a kind of top cone cap. So let's try to bring these two parts together into an assembly. To start, just go up here, click New, Assembly, and click OK. And now with the parts open, you'll see them pop up over here. If you didn't have the parts open, or they don't pop up here, you can just browse simply. We'll start with our cylinder. And let's see. So you see, what I just did now was I went up here in this eye icon and I just showed the origins and the coordinate systems there. So that's useful if you want to drop this part in your origin, so in the center of the assembly. And you see how when I move the mouse over, it'll snap to that. And that's kind of what we want. Another way you can achieve that is just pressing Enter, and it'll also snap to the center. So now we have our first part in our first assembly here, and by default it'll be fixed. So you see that there's a little F here in parentheses, and that means that the part is fixed, and that means it doesn't have mates. So mates are something that we use in assemblies to define how the parts fit together or how they are assembled in a way. And normally we want all of our parts in assembly to be connected with mates. I will just demonstrate how this works on a very simple basis. So let's go in here and click float. And you see now the F is gone. So that means that now the part can actually float, so to speak. It's not referenced to anything. It's just kind of hovering there in space. But we want it to be defined to our center there. So here you have different planes in a part context, but now you also have different planes in an assembly context. And if I move this away and we unhide these ones, let's unhide these as well. And let's unhide them up here as well, so that you can actually see them. Now you can see we have three planes for the part and an origin, and we also have three planes and an origin for the assembly. So we want this to be in the middle of our assembly. We can achieve that in two ways. We can say the origin of the part has to be the same as the origin of the assembly. So I just click and hold down Control, just click Mate, and that snaps it to that. For now, just click OK. So now we see that the cylinder is actually defined with a mate. It's not fixed, it's not floating, it's defined. So that means now we have like a folder here, and it contains one mate. And one mate just says this origin has to be the same as this origin. And that means that this now is fixed. So the second way you can define a part like this is to use the planes of it. So let's remove this one. And you see again now that it's free to float around. So you can just say, I want this front plane to be in contact with this front plane. And I want this plane to be in contact with this plane. And I want my top plane to be in contact with this top plane. Before I show you that, actually, you see, you can drag the part and you can see which one is kind of missing or which constraints is free. And now we get the same kind of result as we did before. But now we have three mates. So often it's useful to just, use the origin if it needs to be centered to the assembly. So just like that. Let's just hide these planes for now. Now let's try to bring in our next part. So you just go up here, insert component. And again, if you have it open in the background, it'll pop up here, or you can just search for it. So now by default, just snap to the center, and it's kind of actually hidden in here. And again, you see it kind of defaults to fixed. Let's just click float here. So another good way to manipulate parts in an assembly is using this triad. So once you unclick fixed and you just have it floating and you just click on the part, it'll come up with this triad. If it doesn't, you can also go in here and click move with triad here. And it pops up this triad that you can just grab and pull. So that's how that works. Now looking at these two parts, how do we want to assemble them? So I would want this surface here to fit inside the surface here. So I just click this surface and I hold down Control key, click this surface. When I release, you have this menu here pop up. And so these are your suggested mates, so to speak. And you can see it already highlights which one it thinks that you want to choose. And that's exactly right. We want it to be concentric. So you see now it's concentric. And you remember when we were drawing with the sketch, we had blue and black lines. So a blue line meant that it was undefined, but black line, it was defined. In assemblies, we kind of have the same thing, although it doesn't really show us, but here you can grab and drag the part, and you can see it only goes in one direction now. And that's because we've defined that these two surfaces must always be concentric. So that tells us that we need to define another mate to keep these parts together. And that would be this surface needs to be mated with this surface. So I just hold down Control while I click those two. And again, it suggests which one you want. And that's exactly right. We want to select that one. So now we have our first two parts assembled. And again, in the just like we did with the parts, you can click a section view and you can go and have a look here. Here you can click keep cap color and it'll kind of color this for you. If you click OK, you can see the lines of the part. Now that we've nailed down the basics of part design and assemblies, let's jump back into our sketch and think ahead. What do we need to create next? So far we've got the main cylinder and the dome, but let's focus on the LEDs for a second. We want them to wrap around the circumference of the lamp in a smooth curved panel, but for that to happen, they need something to mount to. That means we need an internal structure, some kind of cylinder inside the lamp where the LEDs can attach to. But here's the challenge. How do we support a part that's essentially floating in the middle of the design? One way is to extend the inner cylinder outwards so that it meets the diameter of the light tube. That way, everything connects and assembles cleanly. That's exactly what this middle section does. It bridges the core and the outer shell. Now, underneath that section, we're going to design a control panel. So picture this. 3 knobs, one for brightness, one for color, and a third lets you control the LED segments, like a rotating lighthouse beam. Only some LEDs light up at once, giving it a dynamic feel. And of course, we'll add a classic on-off button. Finally, we need a base for the lamp. If you remember from the first video, the design is inspired by a mix of SpaceX rockets and the classic Tintin comics. So we're going with a 3-legged design gear look. And here's the cool part. There's a transparent section that acts just like a futuristic flame, made from clear plastic and lit by the internal LEDs. It's like the lamp is about to launch. Before we jump into the design of the next parts, we need to pause and think about how everything actually is going to be assembled. It's easy to get deep into the design only to realize later that, it's not actually physically going together. In our case, we are dealing with a lot of cylindrical parts that stack on top of each other. Now, using traditional fasteners like screws would be tricky. So why is that? Because there's not much material for the screws to bite into, and the flanges would be tucked away in tight spots, making it almost impossible to reach them with a screwdriver. But here's the good news. We can use the shape of the design to our advantage. Since all the parts are cylindrical and stack vertically, we really only need to hold them all together in one axis. So here's the plan. We'll design each part with a stepped interface so they naturally align and nest into each other. Then we'll run a single long threaded rod through the center. This rod will screw into the top cap, and at the bottom we'll secure it with a simple knot. So when we tighten the knot, it's all held together, just like a sandwich. Now there's a small challenge with the base. We want that glowing LED flame effect right at the bottom, so we can't have the threaded rod sticking out through the foot. Instead, we'll try something clever. A friction fit. So we'll add a few O-rings around the joint of the foot, just where it connects to the lower control panel. That way you can just press fit the foot into place and it'll hold snugly, but still be easy enough to remove if you want to take it apart later. So with this assembly method in mind, we now need to make sure that all the parts are designed to accommodate the central threaded rod. That means running a hole through each component all the way to the top. Okay, so we're now back to our assembly, and let's just start with saving this assembly to our 3D experience. We'll call it Lunar Orbiter assembly, and we'll save it. So now that we have our assembly saved, let's try to create our first in-assembly context part. So to do that, just select a plane that you want to start your drawing on, like when you want to initiate your part. Click front plane, go up here, click new part. And it asks you which plane you want to draw it on, and you just click front plane there. And you can see that now it's created a new part and it's in blue, and everything else became transparent. So this means that you are in a part editing mode within an assembly. So if we were to draw something now and change, it would go directly into the part, not the assembly. And you have to keep this in mind when you draw an assembly context, because sometimes it'll catch you out and you're actually drawing within the assembly, not the part, but we'll get back to that later. So let's try to do a section cut here in the same plane that we're drawing in. And I'll just press spacebar and this view. So this view orients it this way. And let's just see, so we can see our plane. This is our drawing plane. And we said we need to have something that uses the outside diameter here. So let me just try to draw out from here and draw a general shape of what I want to have. I want some sort of cylinder that goes into the middle. I'll click down to the center. I'll click escape. And now I'll click on this one and I'll click construction geometry. So construction geometry is something that will, like, it's a geometry that will help you, but it doesn't actually, it's not included in actually defining the geometry. I'll show you what I mean. So when I click that, it kind of became like a dotted line. And that means it's like a construction geometry you can use like as an axis or help you to define other things and so on. So I'm just drawing the general shape of what I want it to look like. Go again, and I'll just have this as construction geometry. When you do a revolve, you can close the shape, but you don't have to. So in this case, I don't have the shape closed. Let's just open like that. And yeah, what I'm trying to do is I'm trying to create a kind of cylindrical face inside where the LEDs can sit on, and then kind of like a geometry that fits with this outer cylinder. So now let's try to define this. We can drag this up to here, and you see it snaps in, and it realizes here's some geometry that we can use to actually define this. If I just drag it around, I can see that it snaps to something, but it's still like going out and in. So that means that it's caught onto this circle, but it's only a coincident for this line. So just saying that this line has to be coincident with that circle, but we actually want this point to be coincident with this. So just click on the point, control, and click on this line, make coincident. Makes PS. So making it PS means that it will meet the curve that goes through it in a way. And now let's say we want this to have some depth. Let's say 4 millimeters. And this one, let's say this should be total of 190. So let's think about this for a second as well. In our other part here, thinking I want something like this, where we were talking about a threaded rod that has to come up and kind of meet this. So I think I want to have some geometry that goes up like this and kind of meets it, so that when we put it in, it'll hit that surface up there. It'll become clear later. So I'm just drawing some geometry that goes up like that, and then I'm connecting it up so that we're defining it automatically like that. Now I don't need this line, so I'll just use my trim like that. Let's try to define a diameter for this tube where the LEDs goes on. Let's say 35. That might not be enough for the LEDs there. Let's say 33, something like that. And this up here, I just clicked escape to jump to the other dimension. And let's say 15, looks about right. Say this should be a diameter of 25, let's say. So now we have our basic kind of geometry for our LED kind of seating panel. And let's click escape. Let's try to see if this will revolve. So it asks, should I close this sketch because it's not closed? Let's click yes. And we select this as our revolve axis. Click OK. And there we have it. So now we have our first part that's been created within an assembly context. I don't like these sharp edges, so let's try to do something about that. So let's 2 millimeter radius. It looks a bit better. And now this is solid, but we don't want it to be solid. We want it to have kind of like a wall thickness, let's say. So let's try to use the shell feature. Let's say 1.5. Let's try to see how that looks like. There, and let's remove the bottom here. So now we have like a kind of a shell, but this, I think I would like to have that's like solid out to here, and then have the wall thickness from there. So let's click on there, sketch, and let's just use this geometry. I'll just disable this cross section so you can see what I mean. Let's use this geometry here. There, it only took the outer line, so do that. So when it highlights here, it's basically telling you I found a closed shape that I can use for my geometry. So it's happy with that. And you also see that the lines are black, which means that it's fully defined. So one thing I didn't mention before, but it's fairly important, is that you see which is the reference here. It has these little green dots, and this one is telling me that this is being referenced by this edge on this other part in this assembly. You also have something up here. Let me show you in Sketch. Display relations. And here you can just say all in the sketch, and it'll show you what are the relations that are defining these. So if I click here, delete, you see they turn blue now because I've deleted the relations, and now they're not related to anything. So when I drag it now, it's not related, and it won't be defined until you either have a relation or a dimension. And now you see, even though I've created a dimension, it's still not defined. So I know what this is, but let me show you. That's because it has a circle with a diameter, but it's not defined to be anywhere. And you could, for instance, go up here. You could say, okay, it has to actually meet the center origin. And with this point, I was holding down Control, quick coincident, and now it's defined. So that's how you kind of troubleshoot relations sometimes. I'm just clicking Control Z because I actually want that relation that we had before. This is good. So let me extrude that. And I want it to come down and meet this surface here. So I'll go up here and click up to surface, and I'll define up to that surface. Okay, so now let's have a look again. Okay, here. We see that now it's actually solid like we wanted, and we have a wall thickness of 1.5. And another thing that's useful in assemblies when you're working kind of dynamically like this, let's say I changed my mind, I wanted this to be 2 in wall thickness instead. It when you highlight each feature, it'll come up with a defining dimension on the actual model here. This one's kind of like just hovering. You can drag it around and stuff, and you can change this. Just double click and click, let's say 2. Click OK, and it'll update. And you see now it's 2 in wall thickness. If it doesn't update, sometimes it kind of just hangs there. You can go up here and click on this traffic icon, and that's a rebuild. So basically, goes through your model again, and it rebuilds all the dimensions. So let's go back to 1.5. But here it updates. So I'll just add a little fillet here, there, and that's good for now. Now I want this to look like a kind of like a rocket, and we wanted to have little like kind of ribs going around. Let me show you what I mean. So you see how some rockets have these like corrugated panels? So I'm kind of inspired by that, and I want it to be implemented to our design here. So let's try to do that on this one. Now I want to be focusing on this part. I don't want to see all the other stuff. So let's try to just up here, you go back to your assembly, click OK. And let's try to first save this part so we don't lose it or anything like that. We can go here, click right click and rename. Let's call this LD backing and interface. We're now back in our assembly, and I just want to talk about mates again. So now that we've drawn our first part in an assembly context, if you open it up here and you go and look in mates, it'll say that it's drawn in place. So when you create a part, it'll just assume that you want it linked rigidly to the assembly. And maybe you do, maybe you don't. Sometimes you want to move things around and stuff, and it's kind of similar to how the first part you moved in is fixed. Like you can't move it now because it's in place. So we want to have more kind of natural mates that we can manipulate later. So we just delete this one, click OK. And now we see it's free to move again. And you remember how I spoke about these relations that we had that were like moving out? If I didn't fix that while we were in the part and I tried to move this around and the part updated, it would try to keep those relations. So the point that I had out here, if I move this over here, it would try to reach this, and it would usually break your part, and it can be a bit messy. So generally it's good to start out with this relation, because we're just drawing up, you have to have it fit your other components, but as soon as you can define it in other ways, that's generally good practice. So let's try to define this in the way we actually want. So we want this to be concentric with this, concentric there, and you see again. So let me just repeat. So click this surface, hold down Control, click the inner surface, and click concentric. Now we want this part to fit this part. Click OK. And if you look up here, you'll see that there's like a line, and that means that it is defined in some way, but it's not fully defined. This is kind of equal to how there's a blue line when you're sketching. It just tells you that there's something that's free to move. And if we drag in the component, we can see that it's actually able to rotate, because if you think about it, it's still concentric even though it's rotating, and also this plane that we just defined is still in contact, but there's nothing defining it from rotating. And that's actually true to life as well. Like, we don't have any feature that would stop these two parts from spinning together if they were just sandwiched. And in this case, it doesn't matter really. For us, it's fine. Like, it doesn't matter where this is in relation to the other. And the same is true for the dome here, although it's kind of hard to see. One way to see it is if you do a section cut. Now you drag it, you see you can drag it like this, and the same is there. Let's go up. So now, on purpose, I didn't do a little step here, and that was to show you that now you've drawn your part, you've like fixed up your mates, and now you can go and do changes as you see that they are needed. So let's go have a look here. What I'm talking about is that I wanted this tube here to fit into the part with some sort of like step, right? So let's try to fix that. Now in this case, it could be useful that this part doesn't rotate, because we want to draw it on a plane that's known. If we look here, let's have a look at this open plane here. See how these planes are like rotating and stuff like that. Generally, even though it's like a round part, I like to kind of have it locked in so that I know where things are. So if you just click front plane, let's say that it needs to be parallel to this front plane. There, and now it's fully defined. So let's just redo the section view on our front plane. Now when I draw it and I drag around, it won't move on me. So a bit more controlled. Like this way. So now to edit this part, you have to go up here and click edit part. Right click edit part. If you forget that, it's very easy to get started on something, like need to draw something here, sketch, get along, we do lots of things and stuff, only to realize that you're actually still in the assembly, and then you have to kind of throw that work away. So just keep that in mind, that you're not actually editing the part until this is blue. So there, it has to be blue, and you can also see that the remaining parts are transparent now. Click spacebar, front plane, and we want to draw on our front plane. And we do like little want to fill in the gap here. So I want this point to be hitting this corner, and let's say I want this to be 3, and this, do you remember that we set the wall thickness? Oops, there we go. The wall thickness of the cylinder was 2, I believe. So let's create a center line here. And let's just try to draw this out here. This is how you can use construction lines. So so this is our radius of the cylinder. It was 45 divided by 2. And the wall thickness, I seem to believe it was 2 millimeters, which is true. So now we have a line that's defining our inner wall thickness of the cylinder. And we need some sort of gap here, because otherwise it won't go together in real life. We need some sort of tolerance. And usually 3D printing, stuff like that, 0.1 is usually enough. Here we'll do 0.75 or like a snarkish bit. Actually, we'll do 0.5. so that it kind of doesn't rattle so much. And I can also add chamfers in here. Sorry, fillets. Fillet and chamfers and the actual sketch directly. So we'll add that to this. Okay. And now we have a geometry that we want to revolve around this axis. Whenever you have a geometry like this that's away from the axis, you do need to close it. And you can tell that the shape is closed if it has like this highlighted color in the middle. You can also do a right click on a line and click select chain. If it doesn't select a full chain, you have a hole somewhere. So that's useful sometimes when you can't see that there's like a little hole somewhere. Yeah. So revolve there. So now we have our step in now. And I'll just clean this up again. Actually, let's wait with that because we want the LEDs to be sitting on that surface. Click OK. And click save. All right, so now that we've made a few parts, let's have a look at the materials and appearances. So you see how like the parts are all the same color and it's kind of hard to tell them apart now. Let's start with this one. We've got this cylinder and this one should be a transparent plastic. So we'll just click appearances over on the right and go into plastic, say clear plastic. And SolidWorks already has lots of materials kind of built into it, as you can see here. And we want it to be kind of like a frosted plastic. So it kind of works as a diffuser a little bit. And then we want our top cap here to be a kind of like a brushed aluminium. So we go again over here, metal, aluminium, brushed aluminium. Then this internal part will be some sort of plastic. And now we'll just click a low gloss dark plastic. It's like something like that. So now we have some appearances and it's starting to look like what we actually want. So one thing you need to know about materials is that it also works on different levels. For instance, you can have materials that only apply on the assembly level, and you can have materials that apply on the part level. So now I just did this just to show you. Let's go into the part itself. You see the part hasn't actually changed. It's still this gray color, default color. And that's because we've applied the material on the assembly level. If we click on this arrow up here, you'll get this little tab and you can click display pane up here. So this will show you the different materials. And if you click on one of the parts, you click here, appearances. This is where you have your kind of material tree in a way. So it shows you at which level does the material apply. So let's look at that. We'll click on this part, right click, and here. So we see the materials applied on our assembly level. To delete this, then it's actually returned to the default. And now if we go in here, click in, you see that it's gone. It still has material on the part level. Let's open that up. And now if we change it here, we said it was going to be a brushed aluminium. Save that and close. So just a quick tip, when you're in here in a part, you can save by Control S, of course. Control Q will do a update like this, or Control B. And Control W will just close the document. So save it first and then Control W. So now you see that it's actually changed now in our assembly level, even though we changed it in the part level. So it kind of works in that direction. So if the part has a material on its own level, it'll kind of carry that up to the assembly level. So in general, try to put the material on the actual part level. Save that and then do the cylinder. Close that, and I will just delete this top label material that we don't need anymore. So now you see it looks the same as it was before, but the difference is the materials are now on their own level. So that's how you want it. Now another quick tip when working with materials that you can also apply it on a surface level or feature level. So let's take this as an example. Let's say we want this top part here to be blue for some reason. You just select that and I just hold down Shift to select multiple surfaces while clicking on them. And go in here, let's say it's blue. So that's how you do that. And then you can go up here in Display Manager and you can see what kind of appearances we've used. And can go in here and delete it as well, remove appearance, and it'll just return to that one. Because this one was applied on a part level and that other one was only applied on a surface level. Another thing is if you go in here and click there, it'll show you it has applied it on a surface, but this surface belongs to this revolve, that belongs to this body, which belongs to this part. So you can also define materials on feature or body. So let's try the feature. Click escape. Now let's just go and remove it here. So let's say we just want it to be blue on this. So I select the feature itself. Click OK. And then now it's selected on this feature. So if I right click on the surface and I have a look, then you can see it's not on the surface, but it is on the feature there. So now let's move on to building the next part, which is our control panel here. And just like before, let's try to do it in the assembly context. So click new part and also design it on, let's say, the front plane. Here. Let's just get oriented like this. And we want it to be a cylinder. And this center line needs to be in the middle. And we need to have a height of, let's say 80 now. And a diameter of, let me just select this one to be construction geometry. So we'll use that as axis. And this is a diameter of 45. So now you can see it's a little bit harder to work with this because we don't have like a clear kind of what do you say, like an interface there. And also I kind of want to have the origin of my part to be in the middle here, but now we're drawing it in an assembly context. The origin is up here, so I'll ignore the assembly for now while I'm drawing it here, and I'll say this should actually be in the middle here, like that. And we'll just start with our basic shape first. So I'll do a revolve, close, yes. Now we're just doing a basic cylinder. Click OK, and we'll just go back to assembly for a second, because what I want to do now is to orient it in the way that it should be. So we'll go over here and delete our made with in place. We'll move this down and we'll say this surface has to be in contact with this surface. And the should be concentric like this. So now when we open up this part, you can see that it's actually the center of the part is in the origin, the center of the origin, which is what we want. If we didn't do what I just did now, we would have our origin floating up here somehow. So that's not really what we want. Now we also want it to be hollow, but first we want to do a few features because we wanted to have a few buttons on here in the front. So we need like a flat surface where the buttons and knobs can kind of interface with. I'll just first kind of orient the part here. So we are locking it. And I'll also just rename this one. Now that we have it renamed and saved, let's have a look at how we can add these control button surface. So just open the part and let's have a look at these planes again. And let's try to draw a plane out, which we want to draw on somewhere around here. Let's say 20. Click OK. And now let's draw on this. And now we want to make a cut, which cuts out the material from this plane forward. And we want it to be a certain height. So I'll select this as smart dimension, say 65. It's already centered in our origin, which is what we want. But we want these edges here to hit this kind of geometry as it crosses through our plane. And one way we can do that is just select the surface, go up here and click intersection curve. And this will draw lines at which point the geometry goes through your drawing plane. And now we can use these lines as a guide. So we just change them to construction geometry because we don't actually want to use those for cutting. And we'll say this has to be collinear with this. So now we have a closed geometry of which we want to cut out with the material. So go on features, extrude cut, and through all, but not that direction, this direction. Click OK. And now we have a cutout like that. Let's hide these planes for now. And I'll just have a smoother transition here with a chamfer. Say 2.5, looks about right. And let's smoothen out this as well. Say 5, 5. And let's smooth out the edge as well here. Say 3. So you can see how quickly you can kind of smooth out your geometry just using fillets and chamfers. Here, if we look without lines, now we have a nice kind of surface where we can put our buttons and knobs. But you notice that it's still solid. And so this is a good point. You would like to ideally do any kind of geometry on the outside first before you do your shell. And that's because, as we see here now, if we do a shell preview, and with that, the shell will follow your geometry. So that's actually how we wanted it. So yeah, otherwise you would have to cut in and fill and everything, and it would be messy. So now let's try to do some holes for our knobs and buttons. So here I'll just draw, let's say 1, 2, 3. So we're saying that we wanted 3 knobs and 1 on-off button. And so here we have 4 points with 3 lines, and so we wanted to have them equally spaced. So we just make them all equal. And let's turn back our lines here. And now let's just say that we need some sort of clearance from when the geometry closes in on us up here again. Let's say 3.5. And let's just say we want the same in the bottom. So instead of writing 3.5 here again, let's try to use equations. So in here you can actually write different functions, equations, and so on, like using math. But in this case it'll be very simple because we just say it's going to be equal to this. So I just wrote equal sign and then I click on this one. And now this is going to create an equation for us, and that means that if we change this, the other one will follow. So we don't have to change 2 dimensions. And so what we've done here is basically 3 equal length lines with the same spacing on both sides. Now let's try to do the cutouts for the knobs. And I'll use a slotted hole here for the button. Let's just say 6.5 for now. And let's say radius here should be about 2. And let's say this should be about 4.5 per rad. And we'll say these should all be the same, equal. Now it looks already close here, so I'll just increase this a bit. Let's say 5. Okay, now we can use this for cutting through our material. So by default, it just does a through all, but if we did that, see, it just cuts all the way through, and that's not really what we want. We want it just to cut through to the next surface there, and so you just click until next, up till next, and it'll find the next surface. Another way you can do it is you can just click that surface. It depends on your situation, because this up until next, it will just keep looking until it finds the next surface, and that might not be always what you want. But anyway, yeah, we have the part with the 3 knobs and 1 button. I'll save this and go back. So now when we go and do a cross-section view here, we'll see that we need to do something about how these parts fit together. We kind of want this part now to go down and meet this part in the same way that it does up here. So let's go and modify this part. Let's just do cross-section again through the front plane. And we want to reuse this revolve feature that we created on the top, because we just wanted the same feature to be on the bottom side as well. So we need to find a way to mirror it, basically. And I would mirror it through the middle of this thickness of the geometry here. So you can just select this feature there, because that's the midpoint of those lines. And that creates a line that goes through the middle of this thickness here. If you have in the middle of this closed shape, you can select all the lines going around. Those lines we will mirror around this new line we just did. This. Just click now. Okay, now it'll revolve both of those around the center line. Now you see that a fillet we created before doesn't look quite right. And that's because of where it was made in the model tree. So this is something else I want to show you, that you can basically think of the model tree here as like a timeline, and you can go back in time. You can go back like this. You just drag this line up, and you don't delete what you've made. It just becomes suppressed. And this is a good way at analyzing other parts as well, like going back and finding out how was the part actually modeled. So we see, if we look at that fillet we're looking for, that was created there. And that means that now when we are building on top of it, it's kind of staying underneath. So one thing you can do is, like, let's see how it would look if we hadn't created this fillet in that point in time. And I just suppressed it now. That means it just doesn't do that fillet. So here we just have a sharp point. So what would you do now to make a fillet? You just click here, right, and then click a fillet. So instead of doing that, we're still using the same line. We can just drag this down that we used before. And this is just to show you that how you can manipulate your features in where they appear in the model tree. So if you suppress that now it looks all right. So I'll just go back again so you can see it. There, it doesn't look right. Drag it down. And now it considers this geometry that we made before. So that's how you do that. Click save and close this. And now we have this interfacing geometry. And to me, this looks a little bit loose. Maybe we could get away with having it a little bit tighter in terms of tolerance. So now you can actually change dimensions directly in the assembly here as you see them and you notice it. So let's try to remove this. Let's click on this and just click edit part, and then click on this surface, and it'll give you all dimensions that was used to make it. And we can see that it is this one, 20.5, let's say 20.8. Sorry, 20.98, not 2.8. And just click Control Q. And you see now it's changed that dimension. So this is a really good way to work with this, like in a dynamic way. And we can see here the thickness of this, the wall thickness of this is not the same as the wall thickness of that, so we're getting a mismatch. So why not just change the wall thickness of this one? Let's do that. And again, you can just click Edit Part, click on the here, and it doesn't really come up with it right away, but you can click on there instead. Let's say 2 millimeters. Click OK to go back in your assembly. Now let's have a look. This looks better. So next up, let's just cover how to model a knob for this. We want a little kind of knob where we can adjust the light or the color or the orientation of the lights and so on. And we know this hole is about 4.5. So if you click on any kind of feature, it'll show you down here in the corner what's the dimension of it. So you can see very quickly this is 45 and this is 4.5. So I would say let's just start with a knob that's about 8 millimeter in diameter and about 10 millimeter in thickness. So sometimes when you know these things, the dimensions, the core dimensions of the part, it might be easier just to create it as a completely new part instead of trying to do it in the assembly. So we just create a new one, Control N, and click, and we set 8 millimeters diameter and extrude it, let's say 10 millimeters. Let's see how that looks. That looks all right. And we'll just give it a little fillet here on the edge, like that. And now this button needs to work with an encoder, and the encoder has like a shaft with a flat surface on it. So I'll show you how to do that. Let's say the shaft is 5, let's say. The shaft has like a flat surface like this. So we'll just draw a line like that straight through it. And we'll say this line needs to be hitting the origin in the middle like that. And needs to be vertical, so already snap onto vertical. And now we can trim away the things we don't need. We don't need that. Oh, we don't need that up there. So you see now we have that shape we want to use to actually cut in with. And it just needs to have one more dimension. Let's say 2.3. And very important is that if you have some lines that you want to use, but you don't want to include it as like part of the cutting or feature, you need to set it to construction geometry. Otherwise, SolidWorks doesn't know what to do with it. So now we have our outline now. We want to extrude with extruded cut. And we want to not have it cut all the way, but leave a little bit of material in the back. So one way we can do that is use offset from surface and click this. And then just say, let's say 1.5. And now you can see it cuts until 1.5 away from that surface. Click OK. And there we have our shaft hole. Now let's try to make some grooves so it's easier to kind of grip onto. Let's think about how we can do that. Let's create a plane that's tangent to the surface. And let's just define that as being perpendicular to that surface. And let's just do a cut in here. So let's say this should be, leave a little bit of material up here. Let's say, yeah, 0.5 is probably fine. And let's say the same down here. So like before, let's do an equation. Let's say this cut should be 5. Looks about right. But it needs to be in the center. So we can use a construction line. Center line, middle there. Let's say this should be vertical. There. Now let's try to cut. So if you just do a normal cut, you'll see it just cuts like a box cut. But I would actually like it to do an offset cut from this surface here, like so that the bottom is round as well. Now let's try to see how we do that. So we do a offset from surface here. And now you see it's actually round. It actually follows the surface at an offset distance. Let's say 0.15. 0.2, let's say. Let's sit down. So now we have a little cut in there, and now let's try to repeat this gradually. So I clicked the feature first, and up here, circular pattern. And then click where do you want to have it repeating around, and we can just click the surface. And we can adjust this number. It's set to equal spacing for the whole 360 degrees. 35 looks about right. So let's click OK. And now we want to take away these edges here. 0.15. Let's say 30. Something like this, right? So a good thing with SolidWorks is that you can actually, it will suggest what are you trying to do here in terms of fillets. But in this case, it doesn't work that well, I can see. So instead of trying to click all of these lines now, let's just go back one step. And let's say, actually, we'll do it on this level. 0.15. 3 degrees, let's say. Let's do it all the way to the bottom. So now we've ended up with a hole that has like angled walls. Now if we try to repeat that instead, we need to include this chamfer in our circle pattern. Go in here and then include here the chamfer. So that doesn't work because it will intersect itself. So we just have to reduce the numbers here a little bit. Let's say 27, 28. About that is fine. So here we have a feature that makes it easier to grip onto. And you can play around with this as well to make it nicer with fillets and stuff like that. Let's try to make it more interesting here on the end. So I'll just do a little cutout, circular cutout. Let's say 6.5. Let's say just 0.2 in, and we will just smooth out this edge with the same distance. And that looks like that. Now let's try to do something here. Let's try a polygon. Something like this. And let's say this has to be vertical. So now it can just be scaled in size like this. And let's say this should be 4. And then let's extrude that. Let's extrude it up to the surface of this. There we go. Now let's try to round these corners. So if I click one here and I want to round this by 0.5, I click the next one. Now it's like asking me, do you want to repeat that? So you can click whichever one it suggests here, and you can see this is the one we want. It highlights all of the other lines there. Just click there, and that can save you a lot of time. So there we go. And you can go up here and click display styles and have another way to look at it without the lines. Looks a little bit more realistic, right? So let's just remove this sharp edge here as well. Doesn't have to be much, let's say 2.25, something like that. And then now let's change the material. Oops. Let's get the whole thing. Double click. There we go. So that's that knob created. So now as the last step in this video, we'll bring in the knob that we just created. So when you click insert component, it'll already come up here with the suggestions. And we'll just drop it in the field. It doesn't have to be bound to anything right now. We can do that here. So we want that to be on this hole there, concentric. Drag it out again. And let's say it needs to be about 0.5 away from the surface there. So that does some clearance, but there we go. Now it looks a bit long here, it doesn't look quite right. So let's try to modify it in context. Let's say this, just be a little bit that. And you see this works now, and if you think about it, all the things that we made there, we made it relative to each other. So that means that we've actually done design intent without knowing it. And design intent is when you basically design a part to be related to other features within the part, so that you just have some core dimensions you change and everything else will follow. And that's a skill that's really important to learn, because it prevents your parts from falling over. And it also helps you to make configurable parts, which is something that we can cover in the next video. So that is it for there. Now let's also look at how we can pattern parts within an assembly. So just like you can do patterns in an actual part, you can also do patterns with parts in an assembly. And we want to have 3 of these in one direction. So click on the knob and click linear. And now it asks you which direction do you want. And we want it to be like normal to this plane, but in that direction. And we want 3. And we want them to be spaced with some distance. Now, this is another thing. How do you find out what's the distance between these 2 points? So SolidWorks has a tool in here, evaluate. And this is something we'll talk about later as well. But you have a measure tool here, and that's really important. So you can click there, you can click there, and it gives you the dimension. So this is of course a odd dimension because it's equal length to some arbitrary length there. But we get 15.29. So let's go back into here. 15.29. There. If you've made it this far in the video, thank you so much for watching. I hope that you've learned something, and congratulations on your new skill on how to make SolidWorks assemblies and create parts from within an assembly context. In the next video, we'll have a look at how to make the foot and flame and how to work with configuration, as well as how to do the analysis of our design. If you found this video helpful, please consider subscribing, as this is a new channel on YouTube and I'm trying to make more content. Your help will be greatly appreciated. Thank you so much. My name is Raz. Have a good day. See you in the next one.